Hello everyone. Today is March 11th, 2026, and it is a wonderful Wednesday. I am your host, Danno, and I am super excited to introduce a trending article from the archive to you all today. It is another fascinating paper about artificial intelligence and their reality. And I just know you are going to love learning about it. The title is OSS-Liberating AIxCC. Cyber Reasoning Systems for Real-World Open Source Security. The curl is set to receive dual T 2603.8566 phone. It is long, but you don't worry at all, because I am going to break it all down for you, and you'll have a lot of fun exploring these cool concepts together. To start things off, let us talk about the big problem this paper is trying to solve. We see, recently there was this massive competition hosted by DARPA, which is called the AI Cyber Challenge, or Chase-Throwing for short. In this competition, brilliant teams from all over built what are called cyber reasoning systems. These are basically autonomous artificial intelligence agents that are designed to find software vulnerabilities and then actually write the code to fix them. Traditional security tools usually just stop at finding the bug. Like, a fuzzer might make a program crash, or a static analyzer might point out a potential flaw. But then a human developer has to spend hours or days figuring out how to patch it. These new AI systems are totally different, because they go all the way from discovering the vulnerability to proving it is real, and finally synthesizing a validated patch. It is basically like having a super smart robot hacker and programmer working for you, but here's the catch. And it is a pretty big one. After the competition ended, all 7 finalist teams generously shared their code with the world. They made it open source. Which sounds amazing, right? Unfortunately, almost no one could actually use these amazing systems. The researchers analyzed the databases and found 3 massive barriers preventing adoption. First, there was massive infrastructure duplication. Every single team independently built the exact same platform services, like container orchestration and database backends, which makes everything overly complicated. Second, there was cloud lock-in. All of these systems were designed specifically for the competition's massive Azure cloud environment, which required dozens of virtual machines, and that cloud environment does not even exist anymore. Third, the systems were completely monolithic. You could not just take the best bug finder from one team and combine it with the best patch generator from another team. Everything was tangled up together in one giant tangible block. So this is exactly where our hero, the OSS framework, steps in to save the day. The creators of this paper built an open framework that lets anyone run these advanced cyber reasoning systems locally. You do not need a massive expensive cloud setup anymore. You can deploy these systems on a regular server or a strong local machine. It provides a shared infrastructure layer, which takes care of all the messy platform engineering stuff. It even includes a really clever system for managing the budgets of the large language models. Because these AI agents make a ton of API calls to models like Dr. Claude. And if you are not careful, a single run could cost over $1,000 an hour. OSS treats the artificial intelligence budget as a strict resource, just like memory or power, and it stops the system if it spends too much money. Now let us compare this technology with other existing solutions. As I mentioned earlier, traditional fuzzing tools are cost-pros are great at finding crashes, but they do not fix anything. And while there are some newer tools that use artificial intelligence to generate patches, they usually just run in isolation and require humans to double-check everything. OSS-CRS is revolutionary because it is an orchestration platform. It creates an environment where multiple different AI agents can work together in an ensemble. They do not even have to talk directly to each other. The framework uses a shared file directory to pass artifacts around. So an AI agent might find a crash and drop a proof of vulnerability into the folder. And then another completely different AI agent picks it up, analyzes the code, and generates a patch. This is a huge leap forward compared to single-tool pipelines. So, how can this technology actually be applied in the real world? I have these specific application examples to share with you. First, imagine a software development company integrating this into their daily pipeline. Whenever a developer submits a new piece of code, AIxCC framework can automatically spin up these AI agents to review the changes, instead of just warning the developer about a potential flaw. The system will actively try to exploit the flaw, prove it exists, and then immediately provide the exact code needed to fix it. This would save maintainers an unbelievable amount of time and prevent broken code from ever reaching the public. Second, think about freelance security practitioners and small security firms before this framework. Running advanced cyber reasoning systems was entirely out of reach for small teams because it required massive cloud computing resources and limitless budgets. With custom solves, a small security team can run the absolute best AI hacking tools on their own local hardware. They can set a strict budget of $50 for a specific campaign, and the system will automatically route the requests through a proxy, ensuring they never go over budget while still finding critical zero-day bugs in the software they are auditing. This completely democratizes access to elite security tools. Third, this framework is going to completely change the world of cybersecurity research, because AIxCC breaks down the monolithic designs of the original systems. Researchers can now mix and match different techniques. For example, a university researcher could take the brilliant input generator from the first-place team and pair it with the specialized repair agent from the third-place team. They can run controlled experiments to see which combinations yield the best results. This collaborative approach means that scientists do not have to waste time rebuilding the basic infrastructure from scratch every single time. They can just focus on inventing better and smarter AI techniques to prove how well this works. The authors actually ported the first-place system from the DARPA competition, which is called Atlantis, and they ran it through their new OSS framework. And guess what? They discovered 10 previously unknown bugs in real-world open-source projects. 3 of these bugs were of high severity, meaning they were really dangerous vulnerabilities that nobody else had caught. This proves that competition-grade, niche-quality techniques can absolutely be deployed without needing an expensive cloud infrastructure. It's just so inspiring to see how artificial intelligence can be harnessed to make the software we all use every day so much safer. Well, that is all the time we have for today's deep dive into this incredible paper. I hope you enjoyed learning about how AI agents are becoming our autonomous security guards, and how frameworks like us are making these powerful tools accessible to everyone. It is such an exciting time for technology, and I cannot wait to see how these systems evolve in the future. Thank you so much for tuning into today's broadcast. This is your host, Sun No, wishing you a bright, happy, and secure Wednesday. Catch you next time.